Okay. Hi, everybody. Today is Tuesday, July 11th. This is the Kubernetes SIG Testing meeting. It is being publicly recorded and will be posted to YouTube a little bit later. On the agenda today, I'm going to go over some of the issues that we have committed to for the V18 milestone, some of the labeling policies that I put in place, just sanity checking that that's cool with everybody here. And then I will hand off to Chris McClemens to demo the cross-cloud project that's happening as part of the CNCF CI working group. So I'm just going to share my screen real quick, even though this is basically, you're just going to be looking at a Google Doc. It'll be amazing. Okay. All right. So last week I created many GitHub issues that were basically conversions of tasks in the Google Doc that Eric Feda put together that sort of laid out what we would like to accomplish for V18 and what we would like to accomplish for the rest of 2017. So the V18 milestone, also milestone number 3 linked off of the meeting notes here, contains basically everything we think we can get done between now and when the release gets cut September 30th. It sort of seems like the main theme here is to really get everything over to scenarios and to really start moving away from Munch GitHub towards Prow in a more operations-friendly manner. Though at the same time, we do have some efforts underway to make Munch GitHub maybe like faster to restart. We're also interested in things like improving transparency via the use of metrics. So we'd like to be able to instrument Prow and have that feed into Velodrome. I think it'd be cool to see like the flakiness SLA actually get fed over to Velodrome as well. So we can start seeing like if our test performance is really improving over time. And then something I am personally interested in and volunteering for is to allow people outside of Google to be on the test infra rotation. One of the key technical things that's sort of holding us back from that is that we need some sort of tool that can allow this rotation to be driven via something that's not Google. So right now you can go to go.case.io/on-call, and we can see that our friend Eric Feda is the tester for on-call, and Chris Rousey is the build cop. But this is driven via Google internal calendars, and we'd like to find something that lets us sign to other people, such as myself and anybody else who's interested in signing up for these things. Part of this effort is going to involve documenting what the responsibilities of these roles are, what credentials they need to have, what knowledge or experience they should have to be capable of fulfilling these duties. And I think some of the stuff that was going on with the submit queue the past couple of days to me has highlighted, like, I don't actually know what the clear escalation path is to reach these roles and what the appropriate communication paths are. So I'm interested in helping out, trying and failing, and documenting or opening things up as we can. Some of the labeling policies that I did as a result of this, anything that's in the V18 milestone, I assume we are committing to. I anticipate that we should review this as we get closer to release and kick things out of this milestone that we don't think we're going to accomplish. Pretty much everything in this milestone has an area label. That area, kube test, for example, corresponds to code in the kube test directory of the test info repo. Basically, any directory here, I tried to get an area label that lines up with it. So if there's stuff related to Prow, it's area Prow. If there's stuff related to the submit queue, well, that's implemented via Munch GitHub, so that's area Munch GitHub. I know I'm clicking around a lot. I hope this is easy to follow. Other areas that I added that didn't exist before is area bootstrap. That one's kind of weird because there is no bootstrap directory. Bootstrap is a Python script that lives inside of the Jenkins directory right now. But it seems like so much functionality is getting thrown into that. And also we would like to move away from Jenkins that I'm hopeful we can at some point refactor bootstrap into its own directory. And in the meantime, it seems like enough stuff is happening specifically around that it deserved its own label. I also created the area label for the metrics subdirectories and the area label for the kube test directory. There's other stuff like on-call related tasks that don't have an area label right now. I'm not sure what to label them so that we can keep track of them. And then, of course, there are a bunch of issues that are being opened up that just don't have any labels applied right now because we as a team or a community are not being consistent in applying this. So I'd like to actually sort of document this label stuff, send out a note to SIG testing, and then talk about this at the community meeting to sort of help people realize, yeah, unfortunately, there are more repos than just Kubernetes that would like to use labels to start to handle an influx of issues and make sure the right people are doing the right work on the right things. Also, the shrug label is maybe my favorite label of all time. I love to see that it's getting more and more use, even though I have no idea what it means. It's one of those like Godel, Escher, Bach things where we're going to figure it out together. It's a fun journey of discovery. Hopefully that's cool with everybody. If there's nothing controversial here, my plan was to open a pull request and maybe put information in the contributing.md file in test infra, since that seems to be the file that GitHub links you to whenever you try creating a new pull request, just to let you know, like, hey, there are, or when you try creating a new issue, it lets you know that that might be a good place to look for information about how to follow this particular repository's etiquette. Having said all of that, I'm going to stop sharing my screen and ask if there was any questions or comments in regard to all of that stuff.
Sounds good to me.
Cool. Okay. With that, Chris, are you here? Hippie hacker.
I am here. I'll share my screen.
Cool.
Can everyone see my slides?
Looks good over here.
All right. I'm going to go through my slide deck in a minute, but I thought before I start the slide deck, I'll go ahead and do the demo portion. So we have gitlab.cncf.ci, which is a GitLab instance up and running on Packet, and we've imported some of the CNCF projects here. I'm going to go into core DNS and specifically make a change on our current release branch to stable for COA. And I'm just going to make an arbitrary change within the echo. I'm going to get rid of echo goal path. Trigger the CI. I'm going to go ahead and commit that change. We'll come back to this later. This is automatically triggering a change to our CI in this pipeline. And if someone wants to drop that in the channel, it would be great.
Okay.
Thank you. So I'm going to go back to the presentation on the slides now. Present. So what's cross-cloud CI? The CI working group has been tasked with demonstrating the best practices for integrating, testing, and deploying projects within the CNCF ecosystem across the multiple cloud providers. In the notes, there's a link to the kind of call to arms from Dan Cohn. What is cross-cloud CI? For us, we're trying to split this out into two portions. One is the cross-project pipeline. That's helping to create artifacts per commit for all of the CNCF projects, and then taking those artifacts and deploying them across multiple clouds with end-to-end tests. That's so starting out, we've got 3 projects we're currently integrating. That's Prometheus, Core DNS, and Kubernetes. But eventually, we want to target all of the CNCF projects. We do have groups within our CNCF CI instance for all of those groups, and we're slowly reaching out to the different projects to help integrate help with their pipelines. We're starting our cross-cloud deployments to 4 providers, GCE, GK, AWS, and Packet. But eventually, we want to target all public, bare metal, and private clouds as we go along. This is the 2 types of pipelines kind of side by side to kind of split them out. The first one is the cross-project pipeline that each project would have something similar. Building the end-to-end test, compiling the binaries, creating the containers, and then providing a release for this particular commit so that anyone could reuse these artifacts within their own deployment. It doesn't have to be our cross-cloud CI, it could be any other type of CI. Then our second pipeline is our cross-cloud, which integrates all of the artifacts and pulls in those artifacts in the first stage and goes through and deploys Kubernetes on those clouds. And then on top of that, deploying the artifacts, followed by some end-to-end tests. Here's a list of the projects. If you're in the slide itself, you can actually click on this. It'll take you to a link where these projects are on our system. These are the 5 repos we're working with. There's also a 6th, that's the cross-cloud repo itself. That contains our cross-cloud provisioning container and the CI that combines all of the artifacts together. These are the 3 of the pipelines for the projects that we're currently using. Again, they're very similar. Building the binaries, building end-to-end tests. Kubernetes, of course, combines the generation of the containers with the build on the release.sh. We separated those out for Core DNS and Prometheus. This just requires adding a CI YAML file that we're injecting in on our side within the GitLab instance. The release, when these artifacts are triggered, they trigger the cross-cloud repos. And the cross-cloud pipelines pick up the artifacts from all the projects that we've integrated so far, including fresh artifacts for Kubernetes and using those artifacts to deploy across multiple clouds, and then deploying the cross-project portion from all of the different projects, Prometheus and Core DNS, and then running the end-to-end test. There's a link to this pipeline here at the bottom. Might stop for just a second and see how our deploy is going. I don't know if I stopped sharing or not. Let's see. This was our pipeline. And at this point, our Core DNS trigger just 1 minute. If I go to pipelines, we can see that that change that I made is probably finished. And if we take a closer look, we can see that it's generated a release and has triggered the cross-cloud deployment. So we'll drop that link as well, and this has gone through and doing the deploys for the multiple clouds and doing the cross-project Helm chart deploys now. The cross-project pipelines, I'm going to break down those stages a little bit. The build, package, release, and the downstream trigger. The first part is the compilation of the binaries and the artifacts published per commit. Here's some links to the binaries and the environment, the pinnings for the containers that we generate for each of those projects. Those links, again, will work to take us to those artifacts. There we go. And the release artifact for each of these commits ends up being a pinning that has a bunch of environment variables that we can use in any CI system, but we'll show you how we use it in cross-cloud later. There's a registry built into GitLab that we push to, and then we use that later when we pull down for our cross-cloud jobs. You could do anything with those artifacts. I'll dig into what we do in the next section. Here's our cross-cloud pipeline. There's 4 different stages that we go through. The stages are all things within a particular stage are executed in parallel, and when that stage is complete, it goes to the next one. Our first stage is CNCF artifacts. So all of the different environment variables that are pointing to a particular release are collected across all of the projects. And then we go to cross-cloud, which is the deployment of that particular Kubernetes artifact onto multiple clouds. And then we have our cross-project deployment using Helm charts and those variables earlier to deploy those, and then our end-to-end test. This is what those collection looks like at this stage. Each of these jobs aggregate these environment files together. And then we do our cross-cloud deploy. I believe these have links on them to take you to the job outputs. If you want to take a look at the provisioning jobs for AWS, GKE, GCE, and Packet. The result of these deploys are kube configs that are saved as an artifact. In the next stage, we collect those artifacts and deploy using Helm all of the projects that we're interested in testing across all of the clouds. So in this case, just Core DNS and Prometheus so far. The last stage is the end-to-end testing stage. Currently, we're running the upstream end-to-end Kubernetes test, but we publish it as a container within each of our commits so that we can reuse it. I think there was some discussion about that last week. This ends up collecting everything from our cross-project pipelines for all of the CNCF projects into a type of dashboard. So this is the end result of the pipeline currently. Those CNCF artifacts deployed cross-cloud for each of the projects, and then our end-to-end test. That link takes us to the dashboard. And it looks like it's still running the end-to-end test for Kubernetes. So quick overview of what were the technology underneath the CI/CD platform's GitLab. Our cross-cloud provisioning uses a combination of Terraform, Cloud Init, and some per cloud K8 custom configuration. Underneath, after that, we do Helm for deploying our applications for each of the projects, and then each of our pipelines generates a container that we deploy with Helm. So what's next? We're looking at exploring other provisioning methods in addition to ours. Maybe get some feedback on how our provisioning, some thoughts on that. Prioritizing some different cloud targets, whether it's Azure or Bluemix, and we're probably going to not take on any new projects just yet until we get some feedback from the current projects we're working with. Any questions or anything I can dig into a bit further?
So you're doing custom Terraform to do your provisioning, and you're doing it currently across providers, but you're not specifying like what images, because that's an NP hard problem too. So like, are you doing stock Debian, or are you doing like, what's your deployment target that you're using?
Sure, the current deployment target is CoreOS. But it's hot, we can swap it out. We tried to go with something minimal that we could target without doing too many changes. So our target is really anything that supports Cloud Init. We don't SSH out to the boxes after we do the deploy. We just wait for it to come up.
Chris, could you just flip back 2 slides there to that, what is essentially a workflow, I think, and just step us through there in a little more detail. It's not totally clear to me what's parallel, what's serial, and what kicks off what there.
Sure. Let me go to this slide here is a link to this pipeline. So it might be easier to go through the pipeline itself.
Okay.
I will, earlier, I triggered a pipeline for the Core DNS, and I'll go quickly and look at how that's constructed. These columns are the stages, and they're all done in parallel. So everything in build is done in parallel. If that's successful, everything in package is done. If that's successful, everything in release is done. Let me make this bigger so that it is readable on people's screens. I'm just realizing it's probably not readable. Is that better?
Looks good here.
They're all done in parallel. So I'm going to go into this particular commit and show you the CI YAML file. There's the stages, so the columns. And for each of these stages, we go through and run a job that's a part of the stage. The last artifact here is the release. And the release has the registry that we pointed to. So these variables are a link, include pointing to the artifact that we just generated. So this is the container registry for the core DNS. And so for every commit, we have a new container. And we're trying to tie that together so that within our linked job, once we're done, we're triggering cross-cloud. So for any changes with any of the upstream projects, we trigger our cross-cloud repo. Now this is the triggering upstream commit and artifacts, but we need the artifacts from all the other projects as well. So if I go into the Kubernetes job, you can see here are the Kubernetes images and the tags. And this is the stable release, so it includes 166 and the pipeline ID and the job ID so that we could reference a particular CI artifact. We have another set of pipelines for master. So if I go over here, sorry, wrong. If we just click on pipelines, we can see that we also have a master pipeline here that was triggered earlier. And it's pulling in the master artifact. So if we made a change in upstream Kubernetes on master, this would trigger here. And the Kubernetes master artifacts are from upstream master. Once all these artifacts are collected, they're used as part of the deploy. So I'll just, in this column, we're deploying to all of these clouds at the same time. Within this job for deploying to Kubernetes, the first thing it does is pull down the artifacts from the prior jobs, including all of the environment variables for Kubernetes. And we use this within our provisioning. So this is where it calls Terraform and does a deploy to Terraform. And at the end of this, I'll scroll down past everything. We have a working Kubernetes endpoint. And the artifact that we generate is the, we go, move the little window there. Here's the kube config here. And that is passed to the artifacts in the next part of the pipeline for the deployment of the projects via Helm. And these deploy core DNS or Prometheus. After those are deployed on the multiple clouds, we do the end-to-end testing in this last stage. The Kubernetes testers are still running. This is the standard upstream Kubernetes end-to-end test.
What are the arguments though? There's a million end-to-end tests. So are you specifying some crib of the end-to-end test suite?
We're just using conformance at the moment.
Okay.
Yep.
Very cool. One last question about the workflow. So if I understand you correctly, there's basically a bunch of input environment variables on the far left-hand side of that diagram, which come from somewhere. And then each one of the, I guess you would call that a job or process, each one of those oblong things has an implicit set of input environment variables and output environment variables. And those are just aggregated from left to right. So by the time you get to the right-hand side, I assume all of the environment variables generated or set by every one of those things is present in the processes at the right-hand side there, or container executions.
The environment files themselves are just one of the artifacts.
Okay, so they're just passed along as artifacts. Okay, that explains, that answers it, I guess. But there's some logic somewhere that understands that something in column 3 needs the following inputs, whether it's an artifact name with a bunch of environment variables in it, or whether it's the actual environment variables.
Those are defined in the GitLab YAML file, and those are the jobs. And the jobs themselves, they have a depends, and you can say this depends on the artifacts from a prior job, and it would just collect the artifacts for that job. Yep.
Cool. Do you have a document? Oh, sorry. Do you have a document that describes this in detail on how people can contribute?
We're constructing that right now. We hope to have that finished this week.
The GitLab YAML file that's driving this job configuration, what's underneath this? Is this the Blue Ocean Jenkins UI? What's actually running these jobs?
It's not Jenkins. These are GitLab runners. So let me pull up this particular CI stable commit really quick. This is our cross-cloud YAML file. This one's, these are the branches we're pinning to for upstream. If I were to look at, I'm going to change this from CI master to CI stable. You'll see that we're following a particular set of pinned stable releases. And these will have a different set of pipelines based on our deployments. It breaks out the stages, how we grab the kube config and all the environment variables. So this is how we're sourcing all of the environment files from all the projects. And the first set of jobs does the retrieval. So this file here is where the logic for this pipeline occurs. And each of our other projects has a similar file that's much simpler than the cross-project one, or sorry, the cross-cloud one.
So when you're using your deployments, you're not using kubeadm. What exactly are you using to deploy it? Is it kube upscriptory or something?
Nope. I'll let Denver take a shot at this.
Yeah, what we're using at the moment is Terraform has some logic on generating YAML files. So we're just writing env options to pass to kubelet when it starts, and writing the YAML files for the Kubernetes applications. It'll start kube proxy, kube API server, and kubelet reads the directory and starts YAML file.
So you're just dropping manifests.
Yeah.
So if you're dropping manifests, then like you're doing a form of self-hosting, but it's not necessarily what is done in other things. What version of etcd are you leveraging? I mean, like I'm just trying to figure out, your deployment is a particular configuration type, and then your stack and the lower portions of your stack, which underneath Kubernetes, could be variants, right? So I want to know what variables there are and what variables people could tweak. Like what version of etcd are you leveraging, and what version of Docker? It's whatever comes on the CoreOS image, right?
At the moment, in terms of etcd, we're not pinning it, but we want to switch to containerizing that and being able to pass that in as environment variable as well. So we're using this environment for the etcd container. We're using this environment for the Kubernetes components. And then as for using Doc, Containerd, and Rocket, we'd like to be able to switch out those components they're pinning and show a metric of we're using this Kubernetes version on this version of Docker, and it failed on this version, or it succeeded.
So with that in mind, because I have also worked on SIG cluster lifecycle, our stated goal is to create a working group, and the working group is to spread kubeadm across all the installers, right? So that way we have one commonality for how we do deployments, and that will provide you the capabilities to specify the manifest or the versions of etcd that you desire, right? So hence one of the reasons why I think this is kind of interesting, because there will be several folks who will be interested in this.
Yeah.
Yeah, that looks very cool. Is there any concept of limiting the amount of work? Like if I want a certain stage to have a certain throttled at a certain rate, does that concept exist at the moment?
Do you mean within a particular stage or a particular job set, or?
Right, like maybe I have something that deploys a cluster to GCE, but I don't want more than four of those running concurrently or something.
There's not anything in place currently that I can think of, a quick mechanism, but I suspect it wouldn't be terribly hard. A lot of that is around how we do the runners and what jobs they're scheduled with. So you can actually have per job tags that request particular runners, and if there's no more runners available, it will wait. But yeah, no, there's nothing in place yet.
And so then are the runners VMs or containers, or what do they look like?
They're just, at the moment, they're bare metal instances, and the runner is just using the Docker sock on the bare metal instance.
There's also Kubernetes runners that allow us to target a Kubernetes cluster. In some of our earlier iterations, we were creating the cluster on the fly and then using that cluster for the CI job itself as the set of runners for that deployment. But one of the things we found that was nice was having a decent set of caching, particularly for some of the more complex builds. There's lots of options as far as the runners. We've experimented with the Kubernetes runner and then the direct runner on the packet host.
Hi, so this is Chris Hodge from the OpenStack Foundation, and I actually just managed to secure a bunch of hardware that I can use for testing, and if possible, I'd like to help you out on adding OpenStack as one of your stable cloud providers for testing. So if there's something that we could connect with, maybe after the meeting, or later on this week, I think that would be fantastic.
That sounds great. One of the things that we had a blog on that you might want to take a look at in regards to that is our ii.coop. It's not coop, co-op. This last blog post back from January actually has us deploying using an API endpoint. It's something similar to what Rob is doing with Crowbar, although this deployment was using Resin and Hanlon. But would love to reach out for the OpenStack stuff after the meeting.
Yeah. I mean, I think that one of the barriers for us was being able to find a kind of a stable, stable OpenStack cloud release that had sufficient resources for it. And I think that over the last few days, it's something that I've kind of been able to get my hands on, and and I think that it's something that we're definitely interested in, and we'd like to contribute that hardware.
Thanks, Chris.
Yeah.
Okay, cool. Well, that basically brings us to time. Chris, thank you so much for presenting this. This is some awesome tech. Where can people contact you for follow-up or further discussion?
We have a chat area on. Let's probably just do this on the CNCF. What's it called, the Slack. We'll go ahead. We'll update the repo with more information.
Okay.
Within the next hour or two, and we'll send it out.
Okay. I remember right. You work around on the the Kubernetes Slack as well. Is that right?
Yeah, we're on the Kubernetes Slack. I'm on there. We have actually on the CNCF Slack a CI channel, but for the testing SIG, we'll probably just drop some notes in there since this is where this community hangs out.
Cool. All right. Well, thank you so much for your time. Really appreciate everybody showing up. This was a lot to digest. And I look forward to seeing everybody next Tuesday. Happy Tuesday.
Thanks, Chris. Bye.